So I'm sorry for that. I thought I was communicating. So today we're going to be talking about microservices. And just before we begin, how many of you know like what microservices are? Anyone? Anyone with an yeah?
Kind of.
Go on. Dennis, I thought you were speaking.
I said I just had a small idea what microservices are. Like it's when, let's say, a company is building a scalable system rather than doing everything in one maybe code base. It is it splits the system into different segments. Like if take something like large fintech like maybe PayPal, they can have like a section on maybe payments on credit cards, like just small sections, but that make up the entire system. Or you can have something like Uber, they can have something like driver onboarding, or something like clients, like the booking, like all those small segments that make up one large system. Sijui kama nimepata ama, like that's my idea of microservices.
Okay, yeah. Generally, microservices are derived from us dividing like different services of a system into small services for obvious reasons. So, before we begin, I'm going to take you back to where we started before we came to microservices. Initially, we used to design systems like a couple of years. I've decided that have maybe build a couple of systems, maybe be it your final project here or whatever you build as a project. So ideally, everything was smashed in together in the sense that if you want, say you have like a different functionalities within your system, you have users are registering, users are getting their accounts. Maybe let's assume you're building a chat platform like Facebook. So and you build it like before you incorporate microservices. So what you have to do first of all is just a minute. Okay, so what happens is you build everything in together, subdivided by classes and other files. Say you have a class that is responsible for registering users. You have another class responsible for payments, another class responsible for tweets and all that. And you want to maybe call maybe something like a tweet. So basically, what you do is you go back, you call a certain class, and then that class is supposed to feed data to now maybe your endpoint or your front end. So ideally, everything within your system is coupled together, and you use functions and maybe methods to call or maybe classes to call like different functionalities within your system. But when it comes to microservices, you entirely decouple these things in a way that you have an entire project dedicated to only accounts. You have an entire project dedicated to something else like login and registering users. You have another entirely independent project dedicated to another thing. And then on top of below these, all these services, all these projects, you basically sort of build an infrastructure such that all these services are built on top of that. So what happens with microservices and why people really want to do microservices is simply because it's very easy to scale microservices. So assuming you have like just one service, that is responsible for maybe logging in users or creating accounts. And at a particular moment, people are just creating accounts, but they're not like withdrawing funds or doing anything else. And that particular moment, you have so many people within your system trying to access the like they are creating account only functionality and logging in. So basically, what you can do with that is because the whole system is decoupled, you can just spin it into like multiple how do I call it, multiple instances of that service only. So basically meaning that you have more computing power dedicated to only that resource, basic only, unlike you having the entire system working together and most of the other functionalities are not necessarily needed. So let me use the slides that were prepared by Bradley. Uh, so I'm trying to avoid using them so that he can come and introduce them himself. So I can see that he has joined. But that is basically the whole idea of us having microservices. So I believe that was just a basic introduction on microservices. But Bradley, I can see you, right? So would you like to take over?
Yes. Hello,
Hello
everyone.
everyone.
I'm actually sorry for being late. So let's start this session about microservices. Just give me a minute so that I can share the Google side presentation, and hopefully we can start from there. Uh, yeah. Okay. So let me start sharing my screen, entire screen. Okay. So I believe everyone can see my screen, right? Guys, so I don't know how to. Okay, so okay. In order for us to really understand what a microservice is, we have to understand the architecture for microservices.
No
Someone
record.
has okay. So we have to understand the architectures before microservices. So the architectures that existed before microservices that were used were the was the monolith architecture. So what does the monolith architecture actually mean? It's a single unified code base that encapsulates all the complex business logic, the storage, and everything is just bundled down into one code base. And everything that deals with that application is stored in one place, accessed in one place, and entirely if one service goes down, there's a risk of the entire application going down. So that's how the internet used to, I mean, that's how applications were earlier on in the internet. So it created a lot of challenges, like tightly coupled modules. Yeah. So I believe everyone has worked with a moderately large code base and has seen the difficulty of managing the spaces and who accesses what and how one change in a certain part of the code base can break the entire application. It's really painful to handle such a project, especially in a team that comprises of, let's say, 80 to 100 developers working on the same project. So it starts becoming really tough. You have to start giving people really strict rules to manage around. So microservices came to solve this. And these were the challenges that were there in the monolithic architecture. So another thing is everything is developed, deployed, scaled as a unit. So just imagine that the Safaricom, let's talk about Safaricom. Yeah, let's start with Safaricom. I believe everyone knows Safaricom and the famous M-Pesa API that they have. Imagine if they had a system, their whole entire Safaricom system, the M-Pesa and Safaricom was one single code base and was one system. Imagine each and every time that they could introduce changes to the Safaricom M-Pesa API, they needed to build all those products and then ship them out to the user. So each and every time, depending on each and every service that you use, would go down for a certain period when they are making their maintenance, which would be very, very inconvenient for the users. You hear that a certain service, let's say like Paybill, is down instead of the whole M-Pesa infrastructure down. because they actually isolated the business logic for paybill, for till number, and each and everything. They have created microservices that deal with those different payments. That's why it's easy to redeploy that only specific thing when they need to make changes to it. So it becomes also a problem because you have a huge code base and you're replicating instances of the entire code base, and it eats out your server space, it eats out all your resources, and it becomes costly in scaling your application when a lot of users are accessing it at the same time. And also, it confines you to one tech stack. Like, imagine the whole entire team of any company like Google could only be written by one language. What if the language reaches a bottleneck? What if they started to develop something with Python or JavaScript that is single threaded, and the entirety of their project starts to have a limit of how many users can have, because you can only scale a service horizontally until a certain limit, until you have a realization that adding more servers won't add any benefit to it. So tech stacks is not something that you can really plan from before and really have a great tech stack to start from. Most of the people start with one language and they start expanding to other languages because they have adapted the microservice architectures. Because once a certain system that needs to be performant is not performing as is, you can just change that implementation of that service and rewrite it in a language that is more performant, and that's how people do it, right? And also, the release process takes longer because you have to combine the entire code base and ship it out as a whole instead of shipping out services, and also improve the agile methodologies because each team is distributed to perform a certain task. Yeah? So it enforces you to a certain type of methodology of project management that is not very flexible. Reliability. So, in case you're writing on applications, most of the people might create faulty modules when you're working with teams, right? Now, imagine that a module that you're utilizing in your application fails, and the whole application fails because that module was not implemented correctly. It maybe uses a deprecated documentation, that the implementation was switched around and things were moved around. Now, calling those methods becomes a problem. Or maybe in your terminal that you're developing, you created the project in a different version than the one that the other person is developing. You see, all these problems create a very error-prone environment, and this is why people shifted from the monolithic architecture to the microservice architecture. So, so what is this microservice? What is this architecture that we're talking about, and how does it solve this? So it is just a software development approach that structures an application as a collection of small independent services. So entirely, each service focuses on a single focused responsibility that communicates to other well-defined services. So let's say you take each and every business functionality that is core. Let's say like you're doing, let's say you're making a payment system, right? What does a payment need? Okay, you identify all those business logic that can become a unit by themselves. Eh? Like let's say um, confirming the transaction or processing the transaction and initiating the transaction and all these other steps that you take. We can be set as different microservices, and all their business logic, all their databases, and everything that relates with that service is just bundled down as one microservice in a container. So, actually, there is someone who has. Okay, good. So, actually, the most preferable approach is one service for a single specific job. The microservices should be self contained and independent from each other. So it introduces the concept of loose coupling. Someone's mic is off. Please adjust it. James, can you please? Okay, so let's go back. Um, okay, so we saw that in a monolith architecture style of creating a microservice, everything was put in one place. There were dependencies in code. One business logic depended on another business logic. So in microservice, it's a good use and a good pattern to loosely couple these business logics so that one is independent from the other. And one entire business logic can be written and only called when needed by another. So it doesn't need to utilize some functionalities that are in another module. So why should we do this? Okay. The loose coupling, which means each microservice should be developed and deployed and scaled separately without any tight dependencies on the other services, will help people scale the microservices differently. Let's say you're dealing with, let me give you one good example of one essential tool that used a microservice. So who knows about Figma? So actually Figma did a really good job in what they are doing. Uh, it's until I log in that I won't do it. I'll just show you the screen. So they created different services for different views. You see this rendered view here in the Figma, in the Figma application was rewritten in Rust because it is a low-level performant application to do the rendering that was previously initially written by C++. And all these other UIs were written in JavaScript. That is a language that does not need a lot of rendering, efficiency, and everything. And you see these two things are really loosely coupled in a way that they will never really interact unless you try to interact with this service so it shows you a different view. They're tighter, they are coupled in a very loose way that it is easier to write one application with different technologies to best utilize their advantages that they bring to the whole ecosystem of the application. So this was, I think, one of the quick places that I could show you that really utilized microservice. So actually, this is just a diagram representation of a monolith architecture that has each and everything bundled up as one, and then it's connected to the database, right? And you see now there are different microservices here that are actually talking to each other and having one UI. So the UI can be the client, that is the browser, that interacts with these different microservices which have their own databases. So you see they are self-sufficient. Like this microservice deals with this database, so it doesn't need to access this database. It only deals with this. And if it wants to get any information from this one, it has to communicate with this one. And that's how the pattern is. Okay. So after talking a bit about communication, we'll start to talk about communication of different services. Because if this service is split and broken down as a one single isolated service, how does it talk to another service? What essence will it bring if it's just one isolated business logic? They need a channel of communication or a way of communicating with other services so that we actually mimic how an application works, right? So there are three main important communication ways, okay? So there is the HTTP synchronous communication, means that it waits for the message, receives it, and then there is the async message queue, that is actually most of the people use this. So it's the Kafka and RabbitMQ messaging queues are popularly used, and the HTTP synchronous communications, we use normal REST APIs, which were used initially but nowadays are not used. We have the TRPC protocol. It's a remote procedure call, but it's synchronous still. And gRPC, they improve the normal REST API method by being more efficient because they are combined to binary and they have their sizes are relatively very small and they're efficient to just get information around. And there is the third method that is the event driven communication, that is the pub sub communication. It's a model of having publishers who publish information and the subscribers who receive the information. So actually this was used in YouTube, but we'll talk about it in the a bit about it in this we'll talk about a bit of it in our introduction, and I think this will entice you to read more about it and see where they will fall short and how each and every one and each and every way of communication is very useful. So the first one we're going to talk about is the HTTP synchronous communication. So it actually involves making a service and setting an API endpoint that you can access the service from. Okay, so if you want to get information or to post information through this microservice, you do it through a specified endpoint like slash user slash something, and then you get that this is a REST API receiving and getting and sending out information through that specific endpoint to communicate to other microservices and not external users. Okay, so it is a point-to-point communication where the caller waits for the response before proceeding. So that's where this synchronous pattern comes in, so that it is blocking you to wait until the information is received from another microservice. So what happens when the microservice is down? So now we come to see its advantage. It's really simple to understand. It utilizes RESTful communication, which is the standard protocol, and it's actually good for well-defined interactions. So the disadvantage of this is actually it is kind of tightly coupled because you have to actually wait for a service to give you a response or to send you something. So you're actually waiting for receiving an information before you proceed to process it. With increased network traffic, it starts to underperform. And the third thing is potential performance bottlenecks. Okay. Then the second model was introduced, right? An asynchronous message queue. So this came to solve a lot of the problems in communication that were previously in the HTTP method of communication. Okay, so the service that uses the most popular messaging queues are RabbitMQ and Kafka. So actually, what messaging queues do is they really take streams of data that are coming in with a certain key, and the value is the data that they are passing to the message queue. It's like a platform, a centralized platform. So they take and they store those queues because queues have a way of working. It's a first in, first out, right? So the message, when a message is stored in a queue, it can be processed by the microservice when the microservice is available. Maybe it was occupied by a certain service. When it is available, instead of just uh, waiting aimlessly, it can get a lot of, and you can spin a lot of microservices to actually handle the message queues in an asynchronous fashion to just minimize the amount of time that it takes to process those information or those messages if there are a lot. So sending services publishes the message in a service queue. The receiving service pulls the message from the queue and processes them asynchronously. Decoupling allows the services to separately and independently operate without waiting for responses. And the advantages is that it is more loosely coupled, it is more scalable because you can scale the microservices to receive the messages asynchronously without having to wait for certain confirmations. Okay, and it is also fault tolerant because just imagine you're having one microservice and it goes down and you're waiting information from it. It starts becoming a problem, right? So you can just spin up multiple services so that if this service is down, other services can still pick up that message from the queue that was created and continue to process it. Okay. The problem that it causes is that it has an increased complexity uh, in relation to the REST API method. It requires additional infrastructure for managing the queuing system. Okay. And debugging and tracing messages can be more challenging. So it becomes to your way of designing. So you have to really design and put into thought a lot about the messaging queues and the asynchronous properties. Okay. So lastly, we go to the event-driven method of communication, which includes a publisher and a subscriber, right? So the publisher actually publish events. Okay. So let's say this is how actually YouTube works, right? When you subscribe to a channel, you always receive a notification, right? How do all of these people receive instant notification about someone has posted a new content in YouTube in real time, right? So they are subscribers to that service, okay? And that person who is who is creating the content is the publisher. So once the person publishes the information is broadcasted to all of the subscribers. And that's also a method of sending information through different microservices. So it actually focuses on events and reactions. It couples services even further, and it enables real-time reactions. Okay. Advantages: it is highly scalable and fault tolerant. It is flexible for complex workflows and reactive programming, promotes loose decoupling. Okay. And in, the disadvantages are also the same. It is more complex than REST APIs. Um, it requires tooling and infrastructure for managing event buses, and the debugging of event flows can be challenging. Okay, just the design phase of handling how the events will be. You need to have a real-time analysis of how the events play out. So choosing the right communication, right? You can use it is basically the best tool that you can always use is the most simple tool that solves your problem. Okay, so you use RESTful APIs for simple interactions, data exchanges, and well-defined request response scenarios. Like if your system is small, is simple, has simple interactions and data exchanges, there is no point of utilizing complex applications or complex implementations, right? And there are no more, like let's say you don't have a bottlenecks of the people interacting with your services, right? And the other thing is you use messaging queues for asynchronous processing, decoupling, and handling high message volumes, right? And event-driven communication works with complex flow, real-time reactions, loose coupling between services. Let's say you're making the next YouTube, making the next streaming service. This is a good friend for you. So let's go to the additional considerations. Like all these services are internal communications between business logics that are implemented in the backend, right? We need a way for people or the client to interact with it. So it's a good thing that you create an external one API gateway that acts as a single entry point for all the clients to be getting information. And then this API gateway is on itself a microservice, can communicate internally with different microservices. Okay. So service delivery, these are just management tools. So you can go and check out something like Zookeeper, Console, They help services locate each other dynamically because some companies have 500, 1,000 microservices in the likes of Google. Those are really hard to maintain. So they use tools like this for complex microservicing. And actually, microservices are very, very complex to manage when they start to become a lot. So let's talk about CI/CD pipeline. Um, it's easy to integrate and implement a CI/CD pipeline, continuous integration, continuous delivery pipeline, with a small single service and automate its deployment testing without rebuilding the entire process. That's the essence of a microservice, right? And how do we store code? Code can actually be stored in a microservice. You can use a monorepo. That means one code base for everything. And this is how Google actually stores all of its code base, the billions of lines of code that it writes in one code base, and you can use a polyrepo. So most of these new startups and people who don't know how to scale monorepos and offer access to people for specific projects usually prefer polyrepos. So that means you have different repositories that handle different sections of the microservices, and you build them at whenever you need to deploy them. You build them to one build and then ship them out to the vendors that needs to deploy them, like AWS or to any place or message that you need. Okay. So packaging these services, the best and the most efficient way is to containerize your your microservices into a service like Docker. And you need also orchestration tools when you have a lot of microservices to maintain the health and the life cycle of the microservice. What if it dies? What if you need to scale it? And there is also an infrastructure as a code. Those are tools like Terraform from HashiCorp. So actually, these are the tools that you should really take a look at. Um, I think in the interest of time, uh, you have 5 minutes. Okay. Oh, so I actually thought that the time was out. Eh? Eh? Okay. So actually, you can take a look at let's say Kubernetes. I hope everyone is familiar at least with Docker. Docker is just a containerized environment that stores everything that you need to start a project from scratch in a way that is more manageable. Who has worked with any tool, let's say a Python tool or a Node tool, whatever tool it is, whenever you're starting a project, they release version updates on those tools, right? They release a Node update, they release Flask update, they release a Django update. And these are the things that you do not want to have stuck when you're trying to develop an application or when you're working with a team. Someone develops the same application with a different version of the program or the tool that is not compatible with the implementation. You see now that things are happening. So what if we have a containerized environment that takes all the toolings that you start with and it knows that you're using Node version this one, you're using all this everything. It provides you the infrastructure to mimic the environments that you had in your computer when you're building so that it can be reproducible across the whole team, right? So that is a really good tool, right? And that's where Docker comes to solve the problem. So now Kubernetes is on top of Docker. So it is orchestrating or managing the containers because you have multiple microservices in different containers of Docker. Okay. So you need to have a tool to manage those containers. Kubernetes plays a good role in managing them. Okay. Terraform is an infrastructure as a code platform. I really don't want to get into this right now, but go and check out about it. I'll actually attach more documents, um, and you can read on your own time about the difference between Terraform and Kubernetes. I really want to just pass this I want to pass this presentation back to Samson, and I would really encourage you to follow through our second version of this lecture, where we'll be actually implementing um, microservices. We highly advise you to come at least equipped with a knowledge of spinning up a simple REST API of the language of your choice, because you're going to put a lot of things in practice and it's going to be more interactive, and we'll learn along the way. So we'll have a second session where we'll be talking about, and we'll be not talking now, we'll be creating microservices. We'll mimic a service and try to create different microservices, see how message passing is done through an asynchronous message queue, and we try to get really hands-on on it. So we really want maximum collaboration from you guys, and let us now pass the the presentation back to Samson so that he can also offer some value to it. Okay, thank you.
Okay, so in this session, what I want to do is just reiterate on what just happened and then show you something we are trying to build a microservice, show you how the infrastructure is built, and then, but on a very high level because we don't assume that you're going to know like how to Dockerize and create YAML files. So, just a minute. Okay. Can you see anything? Okay. So, what I want to share is this. So, this is a can you see my terminal? Okay, so this is a simple microservice that we are creating. So ideally, I'm going to show you like a couple of them. So from what you see, like we have the first one, this is the infrastructure, and then we have like a demo server. So ideally, what we're trying to do here is mimic uh, a trading platform. So ideally, you have an infrastructure, a demo server. This is going to be, giving you like the currencies, anything that you want. And then we have a data requester. So ideally, the data requester is supposed to go to the demo server and get the data from the demo server. Data processor is supposed to also now get the data that has been requested and then process it. Aggregator. So ideally, some of you guys have tried to trade before, and then you have seen like 1 minute, 10-minute time frames, 1 hour time frames. So how does that come to be? So ideally, you can just bring all the data for a particular period of time, and then save them in something like Kafka, and then you're gonna like calculate their average and then display it to the user. So DB loader, you can save all that you have into your DB, and then you have an API gateway. You can just call this and then submit it. So we have Grafana for monitoring, Kafka, and the rest. So I'm gonna show you from my code base. So I just don't. So next time we're going to do all this physically, but now I just want to show you how it works. So we have our infrastructure, a demo server, a requester, everything. So if I come back to this and then I can spin these Docker containers. So you guys can see the Docker containers are running, even though there's some errors. So just ignore about the errors. So what next I can show you is this. So basically, this is what Grafana looks like in the web. So you can see we have our demo server request. So ideally, and then we have our API gateway. So you can see like these things are moving. So ideally, we're requesting data, sending it data, and doing the rest. So ideally, we've not been able to implement the rest, but you can find this code base in our SE repository. And then, but basically, this is the whole idea. So the schema for this is this. Can you see this? So ideally, we have our demo server here, and we have our data requester. So our data requester is requesting data from the demo server, which is basically a service. And then after we get that data, we post it on Kafka. So we post it on a topic on Kafka. and then data processor will get the data posted there, and then process it, and then paste it in another topic in Kafka for processing. So the data aggregator will get that data. The data loader can also get that data. So ideally, the whole idea for having Kafka is you can post data there, and then every service that wants that data can just get that data and then do whatever it wants with that data. So far, this is just a high level overview. If you want more, we can do another session on this and try to, you guys asking questions, because we don't know like basically what you want with microservices. So we just needed to give a high level overview. So thank you. So far, if anybody has a question, you can just post it or you can ask.